Since the advent of the automobile, we've needed brakes to stop. And for the longest time, these systems are really not all that complicated, and you'd be surprised. But one thing that shocked me is how few people really understand how all of this works. So this video is going to cover some of the basics, and then it's going to cover some of the more complicated things about different types of braking systems from an enthusiast level all the way down to, well, if you're Joe Blow, you're going to understand how this works. So let's get started. Modern braking systems. You're driving along and all of a sudden, like many days, a naked man runs out in front of you and you have to slam in your brakes as much as you probably don't want to. So what happens? Your foot pushes into a pedal, which is hinged. That pedal goes through, the assembly goes through the firewall into a brake booster. What is a brake booster? Just like it sounds, it's a multiplier of force. Because if you didn't have this, it would require a lot more leg effort to push that pedal down to move the hydraulic fluid to all the corners of the car. So the booster has a split membrane with pressures on both sides that helps boost that pedal effort into the master cylinder. That way, anybody can drive a car. If you're older or if you're frail, you don't have to worry about using so much force. From there to the brake booster, you have a master cylinder. And this is what a master cylinder looks like. This is where all the brake fluid or hydraulic fluid is stored. You fill this up, and all that force, this is where the brake booster would be. From the brake booster, it pushes in a plunger. It's just a series of plungers on the inside that push the stored brake fluid out through these ports, and they're connected to hydraulic lines. This is how the fluid moves to each wheel in order to compress a caliper, or you have a wheel cylinder with a drum. So basically, this is doing most of the heavy lifting of the hydraulic system. So you might ask, well, what if it fails and you lose your brakes? Well, it's split into two sections, most of them are. So that way, if you lose one part of it, you still have fluid going to either one half of the car or they split it left and right. So you still have a little bit of braking if this fails. However, it still can leak. Obviously, it's holding brake fluid and there's rubber seals, and like anything, it wears out. Eventually, it will start to seep and you'll start to get a mushy brake pedal if this thing goes out. Now, with many advanced cars, there's different ways they do this. With your traditional cars from pretty much 2000 on, you have ABS. So the brake lines, the hard lines that run from this will go directly into an ABS module. And some of the ABS modules are connected with the ECU for stability and traction control. So a traditional ABS unit will pulse each brake so you don't lock them up. You remove an ABS module and you put your foot to the floor and stop, all your wheels will lock in place when you're driving and you will come to a skid. So the ABS module is just pulsing it fast enough to make sure that these wheels aren't locked up and there's a sensor to kind of communicate with them. Now, after the ABS module, you get into traction and stability control systems, which are piggybacked or separate from the ABS module. What these systems allow the car to do is brake without your intervention. For example, if you go into a slide and you don't know how to correct it, it can individually send hydraulic pressure to one wheel to correct one side to get you back straight. And that's why some of these advanced stability control systems are quicker than human reaction. All you can do is hit the brake. You can't pick which wheel that you want more pressure to go to. That's where the stability control systems come in, and they're a lot smarter these days. So that's kind of just an overview of how all of this works. Now, in that same vein, technology in braking systems. Now, you look at the brake system as a whole and you realize it hasn't changed all that much in probably 50 years. Yeah, components have gotten better, machining and processing, caliper design, all that has improved, but really at its core, it's the same thing. You push a brake pedal down, you send hydraulic fluid to a caliper or a wheel cylinder, and you stop a car. 15 years ago, a lot of the advanced braking wasn't around in terms of traction, stability control, brake force distribution, and a lot of the reason why we're just having this now is because the control units, the microprocessors, the ability to program these is now affordable and it's super fast. And that's part of it. You might have had the technology, but the processing speed wasn't there. And now that it is, you have new modules like the MKC1, which was developed by Continental. It's an integrated unit that houses the brake booster, the brake master cylinder, the ABS unit,
the traction stability control module all in one. And what this gives manufacturers the ability to do is packaging. One, you don't have all these different systems separated. You have it in one small package, and you can implement brake-by-wire. Much like drive-by-wire, it's just a pedal connected to a digital switch, and it's looking at how much pressure and force you're exerting and how fast or slow you're exerting that pedal. And in the case of brakes, it's all software now. Your foot means nothing other than how much you're pushing it. The software, the programming, the algorithms, the tables that they've programmed in here control how much brake force is sent to each wheel, when it needs to brake a wheel or trigger ABS or straighten the car out in a turn. And this is the new trend in technology. All these systems are now software, and they can make updates to it. If you go out and you drive it and there's a quirk or a problem with it, you can either connect to the internet through its telematics system or go to the dealership and they can reflash your braking system ECU to give you the latest programming or to fix something that's wrong. And this is the way things are going. And on one side, yes, it can make a big difference in performance. The other side is, how long does the OEM and the manufacturer want to support this stuff? I mean, are they going to update the car 15 years later when they're way done with this product? And I think for me, like, I drive an older car, doesn't even have ABS. I just know it's just my foot in a mechanical system. I don't have to worry about anything else, and parts are dirt cheap. As with any new technology, costs are going to be extremely high of these systems. Supporting and troubleshooting, including the scan tools and the tools you need, that's one of the negative parts about pushing the bleeding edge of this. Now that you have a better understanding of the technology and the modules, doesn't matter what car you have, typically you have hard brake lines or brake lines that run from those modules to each corner of the car for each wheel. And you'll even see the brake lines running down the center of the car in some cases. Now, I would say 95% of cars have these hard lines that terminate and then run to soft rubber hoses to the wheel caliper or the caliper or drum. And this is extremely common. These rubber hoses are used because of vibration. They are extremely resilient to wheel travel. There's a lot of give. They're good at dealing with hot and cold extremes, and you don't have to babysit them. Even car companies like Ferrari terminate to soft lines. But the aftermarket and certain car companies like McLaren, they do a stainless steel line, and many people will upgrade their lines to stainless steel because there's less give in them. There's less deflection in the rubber under extreme temperatures and pressures, so it gives you a firmer brake pedal feel. That's really what it's about. Now, back to the electronics section. If you have a car with ABS or any of this modern stability and traction control, you will have an ABS sensor, which kind of looks like this, and I have it disconnected right now to show you, and it will connect to the back of a hub. And here you can see the ABS pulsar module. So what this looks for is it's looking at the pulsar module to see if it's spinning faster than another wheel or if it's not spinning at all. And that's how it's calculating each wheel to know, well, do I need to engage ABS because one wheel is stopped spinning, or are different wheels spinning at a different rate at a different time based on the software to know that, hey, you're losing control combined with all the other sensors in the car. So this is kind of where the electronic part comes in. And then we have hydraulic systems, namely brake systems, require a special ingredient, hydraulic fluid or brake fluid. And this is poured into the master cylinder, and it is used and sent down all these brake lines you saw to the wheel cylinders or the calipers. That pressurized fluid pushes those pistons in, clamps the calipers onto the brake pads, onto the rotors or the drum. And again, this is critical to the system. Now, this is non-compressible, which means you can have a really firm pedal. You can't compress brake fluid until you get air in the system. How do you get air in it? Well, over time, brake fluid ages. It breaks down like many fluids, even though it's a sealed system. You can have contaminants get in there from a leaky caliper, for example, or if you boil the fluid. Well, let's talk about that. Brake fluid has a wet and a dry boiling point. A dry boiling point is just that. It's brand new fluid, uncontaminated. So if your endless fluid has a 615 degree dry boiling point, well, it's gonna boil at 615 degrees. What happens? Well, it creates air as it boils. As you get air in the system,
that becomes your more wet boiling point. Or if it absorbs moisture into the system, it reduces the boiling point of the fluid, which can drop down by 15 degrees, it can drop down by 30 degrees. So it's easier to boil the more you boil it and the more moisture that's in it. So for a regular car that you're driving every day, use a regular brake fluid. You want to change it every couple years because it does get contaminated. It can affect your brake pedal feel and the system. For high performance driving, if you're driving a truck, if you're doing a lot of towing, hauling, where you're riding the brakes a lot, getting a lot of heat in the system or track, you want a brake fluid with a higher boiling point based on your application that's compatible with your car. And we're going to get more into this again. This is the basics of all of these things. All right, now you understand how pretty much all the electronic parts work, how you have brake lines that run to your hub where your braking system is. Now, before you get into calipers or drums and rotors, there's a friction material between both of those that help to stop this rotating mass. And this is what you call brake pads, brake lining, shoes, whatever. And brake pads are just simply a piece of metal with a pad material, friction material, that grabs onto a metal disc. And when you get into brake pads, we could talk about this for hours. They come in all shapes and sizes, big and small, like other things. But one of the things you really need to understand about brake pads, much like tires and a lot of things in life, there's not one perfect brake pad for every single condition. Somebody that goes out and goes through the mountains, down, up, a lot of heavy duty braking, a standard, just off-the-shelf cheap brake pad is not going to hold up to those temperatures. Somebody who goes in track drives can't take a regular street pad that comes on 99% of cars and expect it to work and hold up to the heat. So there's different brake pads based on different uses, high temperature, lower temperature, and the way that they give you instantaneous bite, like when you first push the brake pedal when they're cold, can be different based on brands, manufacturers, all of that. But one of the things with brake pads is they're a wearable, consumable item, and they can give you a good feel for if there's anything wrong with your brakes, if you need to switch different types of brake pads, like this one. I heated this thing so much with the ABS hammering effect that it actually bent the metal backing plate. So you can look at something like that and realize, well, I got too much heat in my brakes and I'm overworking them, so I have to make some changes. But a lot of times if you're a normal person, you just want to make sure that you change them before it gets down to that metal backing plate and destroys the whole rotor. We're going to have a separate video just on brake pads and rotors, and I know I'm going to say this a couple times because there's a lot of technical stuff I can tell you about with brake pads in general. Carbotech supplies me with pretty much all my brake pads, and I use these on all my cars now, and the primary reason is they can pretty much do anything for you. Custom make brake pads if you have a specific need for a compound, or the fact that they are not corrosive to wheels and all the other parts of your car from the dust. It won't eat away at everything like certain brake pad manufacturers will, so I like it for that regard. But let's get into the other parts. Now in modern cars, there's two types of clamping devices, and there have been for quite a while. A caliper and a drum type brake. And the drum type brake is really, it's been around. And it's usually used in modern cars in the back. And it's typically relegated to extremely budget cars, eco cars, or something that's really lightweight. Most every single vehicle is biased towards sending all the braking power to the front. And that's really common. And I had a conversation with a guy from Car and Driver at a press event. He's like, why do they keep using brake drums in cars? Why can't they get rid of it? Well, there's a reason for it. One, the drum is sealed. It can last an extremely long time because, again, you're not using it as much. And you have wheel cylinders and springs in there that are hydraulically controlled to push shoes out, as you can see here. Now, the problem with using calipers in the back on some of these cars that barely utilize it is, as Scott has talked about with many Priuses, he'll have a car come in and these people don't drive the car hard and there's a ton of regenerative braking, so they even have to use the brakes less, and the calipers will seize up in the back, or the whole system will rust out. So using a drum brake in that type of application can be very beneficial to a car. And some cars, you can see them last for over 120,000 miles. They're just something you don't have to service as much. But, if you're driving a car that's heavier, you're on the brakes more, or a more performance car, obviously a caliper is going to suit you much better. Now let's go over the different types of calipers. Drums are drums. Really, nobody's advancing that technology anymore. In the case of calipers, you have a few different types. You have a sliding pin type caliper. This is the most common. It has a single piston here, hydraulic line that goes inside this. It pushes a cylinder out through a dust boot and pulls it on this pin or sliding device so it can clamp on both sides of a disc. So when you're using this type, they're extremely affordable. They are cheap to rebuild, very cheap to buy, and this is one of the big things that's overlooked. If you buy a car with a more expensive brake system, multi-piston units that are single or dual piece, and they're Brembos, they're shiny, you can't go to a parts store and get a brake caliper like that. And that's one of the huge benefits of this sliding design. So if you have a car that you just want to drive into the ground and you have to do a brake job, I would rather, this is a much better design to go to an AutoZone and get one for $60. If you have some high-tech caliper that needs to be rebuilt or replaced, likely not a lot of places are going to carry it, especially if it's specialized, or it's going to be extremely expensive to replace. So, weigh that in with, your lust for a high-performance system. Now, that's the sliding type. That's the most traditional you're going to find on almost every modern car. Then you get into something like this, and Essex Brakes in North Carolina supplied me with this and is a demo. This is one of the most advanced modern calipers that you can find. It's called their AP Racing Radical Kit. It has machined material off of it to save weight where it doesn't need it, and this is probably, I would say, more than half the weight of a regular sliding pin caliper. And the reason they trim all this material off is, well, weight reduction, and this is all computer designed. So now you have material where you need it for strength instead of just making this big chunk of metal. The other thing about this is it's forged aluminum, so it's extremely rigid and strong, and this is a two-piece caliper design. Now, if you look at a lot of like Brembos or AP Racing, Willwoods, some of them will be one-piece design where they're completely machined or cut as a one piece. They're not assembled together. That would be called a monoblock caliper. So there's a whole bunch of different types of these. The piston sizes are different on both sides, and that is all about calibrating braking force to your master cylinder design. And you have to pair these up with the hydraulic system. If you just took this and put the biggest caliper on the front of a car that you could find with 20 pistons, that doesn't mean the car is going to stop any better, because you have to understand how much fluid pressure is coming to this and balance it all together. Now I'm going to do a separate video on calipers and brake rotors because there's so much to cover, but I'm going to give you some of the basic information here as well. So there's really two types of braking systems. There's ones that are for track or high performance driving, and then there's street setups. Now, some of the lines can get blurred there, and you'll see this on a lot of street cars where they'll have these big-ass Brembos or, Aki Bonos or whatever manufacturer makes the brakes for these cars, and they look like huge, like, oh, these have to be amazing. And that's true, but a lot of them contain what's called dust boots. And dust boots are designed for street brakes because they seal this piston off from getting debris, salt, sand, other things that you get from regular driving from getting inside and destroying the seal and the caliper. And this is what you would want for a street car. Maybe not this design, but you would want a dust boot. And dust boots really, that's why some of these systems, these big brakes that you see on regular cars, they will still have these dust boots on them. But when you get to track brakes or high performance brakes like this, or this AP caliper, you'll see there are no dust boots on this at all. It is just 4 pistons wide open to the elements. And the reason this is like this is because in high temperature, extreme braking, those dust boots and seals will melt and they turn into what looks like hot fudge everywhere. And that can adversely affect the braking performance just as much as debris. So if you are planning on driving in an extreme manner, I'm talking track driving, and you're going to melt those boots, you're going to have to be dealing with cleaning that up, replacing the caliper, or just switching to a high performance caliper like this without the dust boots. Now, of course, the problem with this is it's not something that you want to operate all year around, namely in winter salt or sand. It's just going to destroy these. So, again, there's no one perfect solution, but that's one of the two major differences between street calipers and track calipers. Now, one of the last things to talk about are the different types of rotors, which is this. And on most modern cars, what you're going to find is what's called a ventilated disc or a blank. It's got a flat surface, no grooves, no slots, no holes, with ventilation towards the middle that is not directional. It just helps to move air along the inside, and this is typically a cast iron disc. Now, every brake manufacturer is going to have different metallurgy, which means the composition of the types of metals that they use on the inside that are proprietary to them. But these are usually, depending on the car, very inexpensive to replace. If you get a high volume vehicle like a Toyota Corolla or something, you could be paying as little as $30 a rotor to replace one of these. So, you don't have to freak out. But if you're driving something like a Land Rover or, a Jaguar, you could be paying upwards of $300 per rotor. That's what that looks like. So the next one you have is a solid disc. This is no ventilation on the center. Now, this does have slots, which you can see on the side here. It can have slots or it can't. But again, this is a non-ventilated disc. Now we get into something that is a little bit different. This is a ventilated disc with directional vanes on the inside, which means you have to put it on a specific direction to create that cyclone effect, to get the air flowing through the middle to cool it better. This is a more performance application. The second thing you're going to notice here is it has a two-piece hat design. Now, when you have a two-piece hat design, it's almost primarily for cooling and weight reduction. In this case, you have an aluminum face connected to the cast iron rotor. So you're going to drop a little bit of weight. You have the directional vanes, and then you have the slots, which helps with pad scrubbing or preventing pad buildup on the rotor face. It also helps with a little bit of outgassing or, sometimes a flow of moisture or water if it gets on there. But that's what it looks like. But this is a two-piece aluminum hat, directional vanes on the interior, and also slotted design. This is a non-floating hat, however. Your next disc is going to be two-piece floating aluminum hat on the outside, directional vanes, and you have J-hooks, which is just a different version of slots. Now, with this type of rotor, when you have a floating design like this, all of these, there's bobbins here that allow the aluminum hat to move or to slide slightly on the rotor. And we're just talking a little bit. Now, the problem with having a two-piece rotor that is fixed with an aluminum hat is when you have the expansion of the different types of metals, that rotor can become deflected. It can warp easier under high temperatures. So when you measure runout, which is measuring the smoothness or evenness of the rotor face across in different directions, with a fixed hat that is non-floating, this rotor face can become distorted and not even, and you can get uneven pad wear, you can get vibration, you can get a lot of that. So having a floating hat prevents that. It also can help with certain things with pad knockback. I mean, really, it's minor. It can help with weight depending on the hat design, of course. And then one of the negative parts of having a two-piece floating design, though, is with that movement, in that the way that the hat can kind of move and adjust itself based on the heat of the two metals, it creates a lot more noise. So that's where, if you're not really driving hardcore, you might just want a two-piece that doesn't move versus a floating design. So that's that. Now, the last thing to talk about with rotors is this is what a brand new rotor looks like on the car and on here. And we're back to the two-piece floating hat. This is a perfectly silver, beautiful looking rotor. And while it looks very pretty, it should not look like this. And one of the reasons one of the biggest things that people don't understand is there's brake pads, obviously, that go on this caliper, which we've talked about. And when you put new brake pads on and a new brake rotor, there's a lot of pad material that gets built up on that rotor. And one of the things that you have to do with it is called bedding. And bedding is just a simple way of saying you need to create a pad transfer layer along the surface of the metal of the rotor. And it's just like dragging an eraser on a desk or on a piece of paper. You create that residue from the eraser on the paper. And that's really what the pad is doing across the surface. And it's getting that pad material into the metal face of the rotor and building up that pad layer. So when you're braking, the pad is riding more on the surface of the metal. So it should not look like that. If you properly bed a rotor, this is again from Essex, which they provide a bedding service, a pad, so they basically do this on a machine to get it perfect. It should have a pad layer all the way across it smoothly, and you should have a nice bluish, almost gray pad transfer layer across the whole face of the rotor when you do this right. Now, if you don't get a good pad transfer layer on the rotor, you can get a lot more brake noise. And this does not apply as much to regular cars. If you just have a friggin' Chevy Malibu, you might not even need to get a really big transfer layer on there because it's going to scrape off and the pads are soft enough on normal cars where it's just going to rebuild itself back up from normal braking. But if you get into a more performance application and you don't bed these rotors and pads together, it can literally create more heat. You can wear the pad material down faster. You can wear the rotor out faster. So it's really important to follow those instructions about mating these two together, doing that bedding procedure when you get a new brake setup, whether it's high performance or not. At least do it once, and then you should be good until you get into high performance applications, which I'll cover in another video. The last brake rotor to talk about is one that is called cross-drilled. Just what it sounds like. It's a solid rotor with a bunch of different holes in it. Looks like cheese to me. And the whole point of that is, one, it's for aesthetics mainly. The second is it helps dissipate some heat. There's more airflow that gets through the face of the rotor, and it helps with a little bit of pad scrubbing, getting excess material built up off the pads and scraping it. The last rotor is carbon ceramic, or a carbon-based rotor, which is a rotor that has a high volume of carbon fiber material in it. It's extremely brittle, but it has an amazing heat range, and this is typically reserved for very high performance cars, something that is very expensive, where a cross-drilled or slotted rotor might cost you a couple $100 if it's really high end. A carbon ceramic disc may cost you upwards of $3,000 to $4,000 for one, and you can't hit it. It doesn't deal with damage very good as their metal counterparts. Now I'm going to get into a much deeper discussion about brake rotors and all the different types and the pros and cons in another video, but this gives you kind of a crash course of the different types of rotors that are out there. So thank you for watching kind of the fundamentals on the braking system. Every car is going to be slightly different, from material choice, pad materials, rotor design, caliper design, fluids, master cylinders. You could have a different OEM for all of those. But again, the basics are the same. So this kind of sets you up for the next few videos that will kind of break down each of these. And I'm really going to talk about the good and the bad of certain things, why you should or shouldn't modify a braking system, and more details on how specific things work. So thanks again for watching. I'll see you next time.